here we are going to look at a simple example that involves two different functions, and one of the function is going to call another function. So we have one leaf function and we have one regular function. So the source is at this address. I will post it on iLearn as well. So as usual, we have some system calls for later use. We don't have anything on the data section. So what this code is doing, it's taking two numbers. So let's say A0 and A1. So let's say 2 and 3. And it's calculating the sum. So we have a function here that calculates the sum of two numbers that we pass to it. And then it's going to print that sum. So basically, these are the two different functions. But also, this sum function is going to call print inside. So not only it adds these two numbers, it's basically summing them. So maybe it's better actually to put them sum and print. And going to update this. Okay, so if you run this code, yes, this should be sum and print also. So if I run this code now, you see we have 2 and 3 defined here. And if I run this, I get 2 5s. So it's not actually 55, this is 5 and 5, 2 times printed. So if I have, let's say 6 and 3, or 6 and 8, I'm going to get basically 14 2 times. Because one time is printed from within this sum and print function, and then one time we are printing it here. So let's see how we can actually do this. So I have defined 4 main label. So I have one main, so that's one label. And I have a sum print number that basically is summing and printing them. And here we are giving the kind of like the header, and I'm saying that what is each register and what I'm expecting. And lastly, I have a print function. And of course, there is an exit. So the way that I'm placing this, before I actually look at the code, I'm putting the main at the very beginning because the order of this matters. And at the end of the main, I'm putting jump to exit. So I want to here basically run jump to those functions and come back, and then here it's gonna exit. So if I had, like, for example, this one at the beginning, and if I would run, I would not get anything. This is actually from the old. If I go back and play, so you see that I'm not actually getting anything. And you can see it actually, if I assemble again and I reduce the speed. So the speed is 1, and then if I play, you see that it's only this 2 line of code that is executed. So the output is actually not printed. So order of this matters. If I put that back to the end, and let's say put the print function at the beginning, it is going to run this one one time, and then it's gonna jump back to RA, which is not yet defined. So let's see what that's gonna, I'm gonna put the speed at 1 also. So you see that it did print a 0. If I go back up, I did see a 0 at some point. We clear this again. I make this slower. Go back. You see that the 0 was there. So if I play again, you see the 0 is there, and then it's gonna jump to RA, and it basically crash because we don't have the RA defined. or probably it's 0. So this shows basically the order of these matters. And how MIPS work, it's gonna start from the text section and it's gonna execute every line, so line by line. So that means it's better to have your main at the very beginning and then you're having your functions. But if you don't have this jump exit at the end, it's gonna basically execute this and then continue to your functions and gonna run every function also once, which is not what we want. Okay, so now let's look at how we are calling these functions. So from main, I do not need to know how these functions are implemented. I'm just gonna look at just this, basically the header that we have, and that should be enough for me. So it says calculate sum of two numbers. A0 is the first number, A1 is the second number, and V0 is result of the sum. So that's all I need to know to run this sum function. So A0, A1 is the first and second number, and V0 is the result of the sum. And then let's look at the print. So we have, so it's a print function, A0 is the value to print. Okay, interesting. So let's come back. So now I want to use this number, use these functions. So I'm defining my two, so as according to this, A0 and A1, I'm putting 2 and 3. And then I'm doing jump and link, and then some print, which is the label that I'm using here for my function. And then here, I don't care how this is executed because I trust basically this function is valid. And here, getting the result as it says here in V0, and I'm moving it to S0. So now S0 has the result of these two. So let's say it has 5. And then I want to call the print function. So this one says A0 is the value to print. So I'm going to put S0 in A0, and actually I don't need this. This is just extra. I'm putting S0 into A0 and calling the print. And that's it, all I need to do. So if I save and assemble and print, this is still on the slow speed. Let's increase it. So you see we got 55 and the 0 is from before. So if I clear this again and assemble and run, you see we get the 55. So basically that's the main. Initializing what we need, jump and link, and then saving the value. So it's very important that because of the conventions that we have, after calling this function, I should not assume that this A0 and A1 is going to basically be preserved. So actually now let's try, and actually I don't know the outcome because I have to look at these functions. But if we have this print, expect A0 to be basically what we want to print. So I'm going to comment this and put the print, also comment this one, put the print right after this sum. So A0 here is 2. So now I'm going to get 5. Basically, it's going to be added. And then I expect to get 2 again. So let's see what we actually, I don't know the answer of this one because it depends on the function. But if I print this, okay, so I'm getting 55. So which is not expected because A0 here is 2. So this is printing a 5. But then this print except A0, it's gonna print A0, whatever A0 is. So if I put like li A0 2, let's say, now it's gonna print 5 and 2. right? Because this print is gonna print anything that is in A0. But if I comment this, you see that it's not 2 anymore. It's printing 5. So that's an example of the function changing values. So if you are just writing, look at this code, if you are just reading this one and you don't know anything about functions, or you don't know the conventions that we have in functions, you're gonna assume that, okay, A0 is 2, so I'm gonna come here and it's gonna be still 2. But that is not true, because the only register that is gonna be preserved across function call, and what I mean by that, like before and after jump and link, is S registers. So that's the convention. Okay, so let's go back to what we had and double check that is actually still working. So assemble and print, we get 5 and 5. Perfect. Okay, so now let's look at how we are implementing these functions. So first let's look at print, because it's simpler. So print, if you remember, we had to put this code, basically the system call, into V0, and we had to put the number that we want to print into A0. But this one, I have removed that line because part of the function call, we expect that A0 to be passed to us as an argument. So A0 is already the number that we want to print. That's why I don't have that extra line here. And I'm doing the system call, which is gonna print that number. But then this is the new part. I'm doing jump register and RA. So this basically gonna look at RA, which is the return address that is saved from here once I do the print. And it's gonna go back to that same return address. Well, actually the next line of that. So once I do this one, it's gonna jump back to the line after jump and link. So it's kind of neat. Okay, so that's simple. Now let's look at the sum print function. So here we are first saving the return address and S0. So the reason that we are saving these two is that this is not a leaf function. So meaning, what does that mean? It means that this function is calling another function. And you can see here that we are calling jump and link print. So this function is calling another function. So that means the return address, so let's say the return address is like 1000, which is referring to this point after this one, after we call this one. But once we come to this function and then we do have this jump and link print, so that's gonna change the return address, basically update it to this next line here. And then it's gonna return to that point after this is executed. But then when we get here, we lost the original return address. That's what was supposed to go back here. So that's why, since we are calling this other function within this function, we have to save that original return address that was used to get to this function, or was used before, was saved before getting to this function. So we have to save this return address on a stack so we can restore it later. So that's why we are putting this RA, we are saving it to a stack, and we talked about how we are saving it to a stack. That's on the previous week. And also we are saving S0. So the reason we are saving S0, that depends on the function. So when I was writing this function, I ended up using S0. There might have been some way around it or not. That's a different point, but I used S0, or I decided that I want to use S0. So that's totally fine. And the only thing we have to do if we are using any S register in functions is to save it also on a stack. So that's why we are saving these two values. And updating the stack pointer looks good. So we're gonna look at this later, but then let's look at here first. So this one is, all it's doing, it's basically reverting these values. So it's saved or store these values, and then here we are popping from a stack and restoring those values back to the original S0 and RA registers. So these two are kind of complementing each other. And then the last thing that we are doing a jump register, which is basically this line gonna be always at the very last line of every function that you write in MIPS. So basically it's gonna jump back to where it was called from. So it could be called from different places, but since we are saving this return address, this gonna go always to the right location. So now let's look at the logic that is happening here. So there is a sum function. So we are adding A0 and A1. So that was the arguments that was passed to this function. So A0 and A1 is being added, and the result is being stored into S0. So now this is our answer. And I am going to call the print function. And the way to call the print function is to put the number that I want to print into A0, as how we defined it here. So I'm putting this S0, I'm moving that, basically making a copy of that to A0. And so now it's going to call the print function. It's going to come back. And then after that, we want to return the value from this sum function. So how do we return a value from some function? We have to put this S0, that is basically our answer, we have to put it in V0. So that's how always it works. So functions that return a value, they have to store their the return value or the result in V registers. So that's what we are doing here. We are copying that to V0. And basically that's it. And if you look back, here we were taking, so it's gonna go back here and we're gonna copy that again from V0 to S0. So this is gonna be the final answer stored here. And one more thing to add, the reason I did use S0 here is that S registers are basically preserved across function calls. So let's say if I did, let's say in this function, I'm updating V0. So let's say for some reason I wanted to do V0 here and save that. You know, because I'm putting it V0 anyway, so maybe I was like, okay, I'm gonna, you know, save a step. I'm gonna put my answer in V0 because I'm gonna return that anyway, right? And here I would have V0 also. But that would change our answer because V registers are not promised to be saved across function calls. So what would happen here, this V0, it would be replaced by system exit code, which is 10. So if I now run this, I'm going to get 5 and 1. I was expecting 10. Yeah, see, like unexpected things happens. So 5 is the same time, the first time that is printing, and then print int is, oh yes, sorry, print int is actually 1. That's why we are getting the 1. So basically we are messing up our answer by doing this. Because here the V0 is updated and I had my answer in V0. So basically these two are conflicting. But if it's on a vest, and this is this is like me knowing what's happening in this function. But ideally, you are not supposed to know how the function is working. You should just know its implementation, as in you should not know the implementation. You should just know the interface. So you should just know that you get A0 to it and it's gonna print. So maybe this one wants to do a bunch of things in between. That is allowed to. But what you are sure is that S is gonna be preserved. So that's why you have to put this one on S and keep this on S, and then later on move it to V0. You cannot put it directly to V0 here. And now it should work as intended. And we get the 5 and 5. So this is a good example of basically having a main and calling a function or calling two functions that one of them is a leaf function, but the other one is not a leaf function. So we have all these saving mechanisms here. And the last point, even if let's say this was a leaf function, we still would need to do this saving the variables on a stack if we were changing the S0. The only difference is that we don't need to change, or we don't need to save the return address because we are not calling any function, and that's gonna be preserved basically.